Thank you all for showing up here on a somewhat rainy afternoon on the last day of DappCon. My name is Sebastian. I'm founder of Hopper, and I'm very happy to talk to you about a topic that's kind of dear to me and I think very much overlooked in the wider Ethereum ecosystem. So, is there anyone in the room who has an Ethereum wallet? Hands up, please. I see a few hands. That's good. Cool. So, I aim at making this a more interactive workshop. So, yeah, we're going to play through some stuff. And my objective here is to first make you aware of what the issue is with wallet privacy on a layer that's not so much talked about. Secondly, briefly talk about what we do at Hopper. And thirdly, present a latest project that we're just launching now to fix that. And yeah, that's what we'll be talking about in the next 45 minutes or so. If there's any questions, please interrupt me anytime and ask. If there's any technical issues, my colleague Felix here in the front, also in a yellow t-shirt, is very happy to help you throughout the workshop. So after we've seen that there's some people in the room who do have an Ethereum wallet, that's great. I would like to make you think about, do you have something to hide? Right? And you might say, no, I have nothing to hide, right? But this is the wrong question when we think about privacy. Right? So privacy is really about getting these fundamental human rights back into the digital space. That's what this is about for me. For me, this is not about, oh, I'm not an illegal guy, I didn't trade on Silk Road. Most people who entered crypto early did trade on Silk Road, and I don't judge any of that. It is about giving you the human rights that we have in the real world and try to bring as much as possible of that to the digital world. Because without that, this digital great new world that we're building for us and for the generations after us who are building amazing things is just corrupt. That is, to me, what the Web3 should be all about. Now, as we enter the Ethereum ecosystem with our wallet, there is your wallet, which is kind of naive. It doesn't know what's going on in the world. In fact, your wallet is a pretty dumb piece of software. It can typically store a private key, more or less secure, can make transactions, but that's pretty much it. Specifically, your wallet does not know, for example, your balance. It needs help. And the help that your wallet gets is coming through a so-called RPC provider. RPC stands for remote procedure calls, and it's what your wallet does in order to get some information, such as what is my ETH balance, what's my ERC20 token balance, what is the current gas price, and stuff like that. So the first thing that we're going to do is we look at, there's a bunch of people here who I know are familiar with all of that. But we will look at that in a practical setting because I promise you there's going to be some things that even the ones who are more familiar with Ethereum for many years already will find surprising. So the first thing that we're going to look at is DERP. DERP stands for Dumb Ethereum RPC Provider. And basically, all that DERP does is it serves information to your wallet and it echoes it back to you. We made a nice website, which makes it a bit more interactive and tangible, because otherwise the data which is made available to these central providers, which are seeing and helping out your wallet with all the information that it needs, it's something abstract, right? Metadata is something, I care about my IP address. Well, bad news, it's much more than your IP address. So the first thing that I would like you to do for the ones who want to play along is navigate to DERP, that's derp.hoppernet.org, HOPRnet.org. You can do this on a mobile. It is a bit more cumbersome on a mobile. So if you do have a laptop, I would encourage you to do it on a laptop, just because you can have multiple windows at one instance. Now, what this thing is again, you can add an RPC provider to your wallet and it echoes it back to the website. We call it Dumb Ethereum RPC Provider because we don't actually do anything with it. In fact, how it works is, by the way, you'll also find the code for all of this as everything we do on our GitHub. So if you want to mess around with this for other purposes, please feel free to do so. So what this does is actually, we have a server which just proxies requests. Right? It takes your request, It sends it to some other provider that we have configured, and it also like echoes it back to your website. We don't store that information. Of course, you have to trust me, right? It could be that we're running different code there, so don't assume this is private. Just as with any other RPC provider, do not assume this thing is private. Do not assume that we are good guys. And yeah, then it's mirroring it back to the same IP. I just realized we are all connected to the same IP address. I'm pretty curious how this will work. Let's see. So I'm going to demo it to make this, at least for me, a little bit quirky. I'm going to be connected to my hotspot. The second thing, if there are some quirks here with everybody having the same public IP, do not do that with a wallet that you don't want everybody else in the room here to know. Yeah? So I'm going to talk about privacy, but in its demonstration purpose, you might leak information about you that you don't want to leak. If you don't want to do that, don't go ahead here. Do it from your home, from an isolated network, and so on. So I'm on the DERP website. Again, it's derp.hoppernet.org. And I am using MetaMask. This does work with most other Ethereum wallets that I'm familiar with, just to make it easier to follow along, because I know MetaMask is not the prettiest wallet, but it's the most popular one. I'm going to demo it for MetaMask. So I'm going to hit that setup button, and you can actually see that. Let me make that a bit bigger. So you can use DERP on various chains. And again, all that we're doing here is we are adding this endpoint to our wallet now, and what our server in the background does, it just proxies it back to some other provider. So I am going to be, since we're in Berlin, I'm obviously going to do that on Gnosis chain. So I have my MetaMask unlocked here. By the way, you saw that little glitch when it took like half a second to load, like this little MetaMask moment. We will look in a second what that MetaMask moment actually is. Like, why does that happen?
So you just give that URL again for DERP?
Yes, it's derp.hoppernet.org, HOPRNET.org, derp.hoppernet.org. Yeah, so basically I have my MetaMask, I have it unlocked. By the way, there was a new version of MetaMask coming out last night, but it should work with either. They now have snaps integrated, which is awesome. So I'm going to hit switch, and now you'll see that it adds this endpoint to my MetaMask. It asks me, do I want that? And in my case, yes, I do want that. So it just asked me to confirm that. Again, like what's the worst case trust assumption at this point? Like MetaMask asked you about something, hey, watch out. Like at this moment, you all should be, do I trust these guys? So the worst case trust assumption here is that this provider sees absolutely everything that your wallet does, okay? Just for your info. I'm going to prove it, and I'm going to switch the network from Ethereum mainnet to DERP Gnosis chain. Switch network. And I'm going to scroll down here, and there's a bunch of interesting things going on here. So first of all, it shows me I'm in Switzerland. That's weird, right? This is my IP address. Why is that? Because I'm connected to my hotspot. Yes, I doxed myself as having a Swiss carrier. And you see already some addresses here. You see chain ID, and you see that it made 7 calls. Like, okay, interesting, right? So the RPC provider was already being informed of my Ethereum addresses. Anybody got a clue why that is? I just connected it, and the RPC provider already knows my Ethereum address. I didn't make any transactions. Why? Query my balance, exactly. So in the table down here, we see the actual requests that are being made. And what we see is that, let me try to see the ordering of that one. So the latest one is on top. So basically what it did is an ETH get balance. So for the ones who are not familiar with Ethereum RPC calls, it's basically a server, and on the server we're calling a function to say get me my balance. And the function that's called get me my balance is called ETH get balance. That's the endpoint. That's kind of obvious, right? And in order to find out my balance, it needs to know my Ethereum address, and that is this one here. Now, what is maybe a little bit less obvious is that there are additional so-called header fields in these requests, which reveal already something about me, right? So this is all metadata information, which, if you actually think about it, the provider has no point in knowing, right? There's absolutely no reason why a provider would need to know that I'm on some, Mozilla-based thing on a Linux, and a bunch of other information. So it's a bit weird. It's oversharing. And the more important thing I find is up here, my IP address, right? So the provider at this point knows about my IP address. And at this point, I would like to make a little pause because I sometimes get this feedback of like, okay, Sebastian, surprising. The RPC provider knows my IP address. Tell me something new. And I'm saying, well, that's private information that is not necessarily shared with them. Okay, fine. I'm not so concerned about sharing my IP address. What are you going to do about that? What I am concerned about is linkability. Who here has more than one Ethereum address? Okay, 1 or 2 people, good. Now, maybe some of us have an ENS domain that is linked to the name, like I have like SD Buergel, which is my handle that I use all over the place. I have a POAP address, right? Patricio running around here. Everybody that runs into Patricio gets a POAP if they want it or not. You collect these things that are tied to your face, to your real world identity. And many of us have, some savings in crypto that do not necessarily need to be tied together. You should have the right to separate these two. Now, this provider here can link them. This provider now sees that the exact same IP address queried, within very short time. Actually, if you look at the timestamps here, it's kind of funny. So within the same millisecond, you get hit from the same IP address with, an ETH-GET balance request from 2 different addresses. Well, probably that person is controlling these addresses or was sitting in the same room and so on. So yeah, that is something that I find much more concerning, right? So that is something that I find much more concerning than just sharing my IP address is linkability. The second answer that I sometimes get is, well, you're a pleb, you use a centralized provider. I'm a smart boy, I run my own Ethereum node, I run my DApp node. That's cool, but let's think about what that means. You use your DApp node, and these read requests to check your balance and so on, they all go to your node, and your node doesn't inform anybody else. That's okay. But when you send a transaction, this transaction is being sent through your DApp node from home. That doesn't originate any other type of addresses. So it is pretty trivial for other participants in the network to find out where that transaction originated from. So your DApp node, your own Ethereum node, is in fact helping you for reading. It keeps reads private because it isn't shared with anyone, but it does not keep writes private, right? Writing to the blockchain is not kept private because your DApp node or whatever you use is synonymous with your identity. It's exclusive. In other words, as we sometimes say, privacy loves company, right? So you want to share this thing. But then again, you have a provider which other people need to trust. What do? I also sometimes get the answer, well, I use a VPN. Okay, let's look into that. You're a smart person who uses a VPN. A VPN is great because that VPN that RPC provider doesn't see where you live. They don't see your IP address. But I'm not really concerned about that because this information of my IP address is not really concerning. I'm concerned about linkability. So in essence, you're changing one centralized provider, which is like Infura, Alchemy, or some of these other RPC providers, with another one that's called a VPN provider. I have no reason to trust one more than the other. It's a centralized trust assumption that this person and all the people in that company don't violate that trust. So let's think about how that actually is in terms of privacy under this threat model of I'm concerned about linkability. Use a VPN provider, okay, like NordVPN, something, hopefully something, more legit. This VPN provider has a bunch of servers. So your anonymity set, so the number of people who could be you, is the number of people who use your VPN provider on that very server that you're connected to at that exact time with the same metadata information that your wallet produces. I can guarantee you, whatever VPN provider you're using, you are alone. Your anonymity set is going to be 1. So in terms of linkability of addresses, that's not really going to help you. That's not good. So we're going to fix that, but first of all, I just want to show a few more things that I find kind of interesting when looking at this thing here. So first of all, like for you all here in the room, do you see everybody's request actually? Yes? You see like a whole lot of other addresses which are not yours? Yes or no? You just see yours? Sorry? There are more. Cool. Okay. So, welcome to the club of, Ethereum addresses in this room. Congratulations, you doxed each other. So, yeah, let's look at what is actually going on as you interact with a dApp out there if you do anything, right? Because it gets worse with regards to privacy. So again, for the ones who didn't manage to set it up at first, you just go to derp.hoppernet.org, derp.hoppernet.org. You hit the setup button and you add this network to your MetaMask. Now, what happens actually so far is kind of, not surprising. MetaMask is querying the block number, basically asking, hey, provider, what's the time right now in terms of, block number. We just see the request, we don't see the response, because the response is kind of, it doesn't matter, you can always kind of reconstruct it from the request. So I didn't do anything, so all the time while I was talking, my MetaMask seems to be every 30 seconds to be querying the current block number. Fair enough. So let's do something. I'm going to send myself some ETH. By the way, if you want to do something cheap, I encourage you that you do that in Gnosis chain. There is a faucet called gnosisfaucet. Felix, what is it? gnosisfaucet.com.
You just look for Gnosis Faucet.
Yeah, gnosisfaucet.com. You can request like a fraction of an XDAI, which is kind of cool to just toy around with it. Now, the first thing that I'm going to do is I will, what am I going to do? Is I'm actually going to use sushi. Like sushi is kind of like, yeah, it's kind of interesting to look at. So I am going to keep my browser windows next to each other so we can follow the new requests as they come in as I'm doing stuff here. So far, MetaMask is just querying the block number. I'm going to, oh, okay, that's a bit lame because I'm already connected here. I'm going to disconnect. I'm going to reconnect my MetaMask. And I'm going to start a swap. So SushiSwap already knows that I have 0.3 XDAI here. And I'm going to switch, 1 cent for GNO. It's going to be a tiny amount of GNO that I'm going to get out of this one. Okay, I'm willing to swap for it, right? This is just front-end interactions. Now something interesting starts happening here. It does an ETH get code, right? What is ETH get code? Well, ETH get code is just a request to get the bytecode in the EVM at that address, which is probably the sushi router. Let's quickly check it out. Gnosis scan.io. It's the Gnosis Blockchain Explorer. I'm just going to copy paste the address. I'm going to look at the contract, and indeed it's the root processor number 3. Okay. We're looking at this from a privacy angle here. So what does that leak about you? That leaks to the RPC provider that you're about to use SushiSwap, right? Okay, whatever. It does an ETH call. Okay, interesting. Well, it's the same address. And now we're calling a function, we're reading, right? This is a read on a smart contract. So what are we reading here? So if you're new to Ethereum, like you might be interested to hear that the first 4 bytes of this thing, so the first like 10 characters encode the function of what we're calling there. So I'm going to copy paste the first 2, 4, 8 bytes of this. And there's a very cool website called 4bytes.directory. 4-byte directory that allows you to do a reverse lookup of this function signature. And yeah, this one is since just first 4 bytes, there's some overrides. So the first one I think is just some bullshit thing where somebody found a hash collision. But the second one is most likely what I'm actually going to call, which is supports interface. right? So it's basically trying to find out like if the smart contract supports something. I don't know exactly what it does. So another ETH call, a bunches of ETH call, and a fee history, right? So now somebody's querying kind of what is the fee history, so how expensive is it going to be if I make a transaction? And now something very interesting follows, ETH estimate gas. So if you look at this ETH estimate gas, that's basically asking, hey, tell me how much gas do I have to spend for this transaction? And that's basically just so that your wallet knows how much to send along. Again, very boring, I know most of you know it, but think about it from a privacy perspective. What does that mean? We might trade, you know, $1 million worth of stuff. What happens when you trade $1 million on a kind of naive AMM? You know, there's front running, back running, all this fun stuff called MEV. Cool. Now you are sharing with the centralized provider what you're about to do. This is not a transaction. This is something that you're pretty certain you're going to do because you just hit the button what you want to do. So you see in this transaction, like this from addresses me, you send something to the sushi router, you see, you know, exactly how many extra I'm going to send along, and a bunch of other things. This is like route information and the recipient address, and I don't know why my address is in there twice, actually. So you disclose everything, what you're about to do, before you have even signed it. Now, congratulations. I can tell you what I'm going to do with that information if I'm an MEV hunter. Yeah? So, again, if this is nothing new, this is all cool, but let's think about it for a second, the direction in which Ethereum moves. Ethereum moves in the direction of decentralization. I'm all up for decentralization. I want decentralization of power. I want to see decentralization of infrastructure. But this information is currently going to, you know, if you're on mainnet, chances are it goes to, you know, Joe's basement, and we all trust him. Maybe that's fine. Let's fast forward. You know, there's people working on decentralized RPCs, which again, I want to see decentralized RPCs. But there's now a random lady on the internet or a random dude on the internet that you trust with this information. Is that going to end well? I don't think so. So in order to decentralize infrastructure, we need privacy building blocks in order to use that safely. So that's what this is about, and that's what I want to think about when I see these things. So you disclose something that is not signed yet, so it could be bullshit, but chances are this is real, right? If I observe you for a long time, I'm going to find out patterns, and I'm going to be able to front run everybody else because I know what you're going to sign in a minute from now. So that's why I find it kind of interesting to look at these things. Okay, I was talking for a long while, so it was querying my balances, getting block numbers and whatnot. Now, let's actually go ahead and sign this transaction. Cool. Confirm. I signed it. We see an ETH send raw transaction. ETH send raw transaction takes the signed transaction, broadcasts it to the network. That's the thing that now, you know, if this was mainnet, where a bunch of searchers would jump on this thing and go like, you know, goblin mode on that one, try to find out how they can screw me. So, and if you compare these two, requests, it's a bit longer to scroll, but you might remember it. They look quite similar. The only thing that's different is the signature. The signature is the only thing that's different in the second one compared to the first one. And yeah, so there's an opportunity to front run the front runners. If you're an RPC provider, there's a lot of other information that you leak even before you signed that actual transaction. Good. Okay, so that was basically something that can go wrong. I want to show one extra fun thing. I told you like this little MetaMask effect when you like clicked the thing the first time and it was stalling for a while. I promised you we're going to look at that, you know, what actually happens there. In order to look at that, I'm going to close my browser window. It's going to be probably a bit more messy for all of you who share the same anonymity set there. What I'm going to do is I will actually, by the way, shout out here to CubesOS. I find a wonderful privacy respecting and safe operating system. I'm going to open a separate VM here just to keep things super separate. And I'm going to open this website again just to, you know, visualize that I'm not cheating. So currently my MetaMask is closed. MetaMask is not running. That's why it doesn't show any requests. Yeah. So, oh, interesting. You know, something somewhere is querying an ETH block number. Now that's weird. Because I had this one open. Okay, well, fail. Cool, reload this. Now, actually, everything else is closed. So I'm going to open my demo VM again. I'm going to open my Brave again. Okay, there's a bunch of requests. Yeah. Interesting, right? My MetaMask is locked. Yeah, my MetaMask is locked, and yet it already made a bunch of requests to the RPC provider I'm connected to. Luckily, in this example, it didn't leak my address yet, but it made requests to an RPC provider which revealed private information about me, such as my operating system, my IP, the browser version that I'm using, the wallet version that I'm using, and so on before it's unlocked. So, and the next thing that you see is, as I scroll down here on the right, let me minimize that one. Okay, Sushi wants to connect to it. Let me close Sushi. If I hit this MetaMask, you see this request going out here? So MetaMask is making a request. It seems to be synchronously waiting for the request to come back, and then it loads the UI. So that stuff that you see when you kind of look at the requests in parallel. That's why we have this MetaMask second when we load. I don't know why they do it that way, but we see it. Good. Okay, I don't want to dive any deeper into the issue of what your wallet leaks about you. I think it should be evidently clear that an RPC provider is a centralized point of failure which we trust with a lot of metadata that can be used against us as individuals which are interacting with the Web3. I don't care if you're doing $1 million trades on Uniswap and you can get front run by some searchers, or if you're sniping an NFT where somebody's trying to come first, if you're interacting on Web3 social where people kind of can see what you do and who you interact with even before it happens, you're being watched all the time, and it's something that needs to be fixed. There's a lot of people working on on-chain privacy, and I really hope that happens, but on-chain privacy isn't enough. We need transport privacy to protect this, sometimes they call it Achilles heel of Ethereum, because, if we have on-chain privacy and your IP address becomes your primary identifier, that doesn't help us much. So, luckily, somebody's working on it. Yes, it's us. We are at Hopper. And let's briefly talk about what we do at Hopper. Let me open that up real quick. So basically, Hopper is a mixnet. What is a mixnet? A mixnet is a network for relaying data. So I can send data to someone here in the room by sending a data packet to you, who relays it to the next one, who sends it to the final recipient. So I'm forwarding data packets, so the recipient of these data just sees the last, sometimes also called exit node. They don't see the previous relayer or the previous relayer before that, or even the sender. It's obfuscating where data came from and where it goes to. And again, there's some people in the room here who have heard about VPNs, we talked about it, or Tor, and indeed that is something that sounds very similar to Tor. You have this multi-hop relaying of data that is very similar to Tor. But there is 3 important differences to Tor. The first one is we do what is called packet mixing. So as visualized there, data packets are coming into a mix node. This mix node is caching data packets for a short amount of time, transforming them so they look different and indistinguishable when they come out, and sending them out in a different order. And that is how even a super strong adversary, let's say your internet service provider, who sees every packet that goes into your router and every packet that comes out of your router, cannot link incoming and outgoing traffic. That's something that you don't have in Tor, because Tor takes packets and sends them on, and you can kind of tag them. A mixnet, therefore, has stronger privacy assumptions than Tor. Specifically, the trust assumption of a mixnet is that only one node along this path is honest. If you have one honestly mixing node along your route of multiple hops, then you're fine. Why? Because this mixing and tumbling of data cannot be linked. Cool. So the second one is that this is, of course, a decentralized network. So it's a bunch of relayers in this network. And the third one is that people can make money by doing so. So if you relay data for others, you earn Hopper tokens. So the people who operate these nodes. They stake Hopper tokens in order for you to use that and gain privacy. That's the Hopper network, and you can use it for general purpose application. You can build a private chat app on top of it. And by the way, we've done that a while ago. You can use it for a private IoT app. Or, coming back to our wallet problem, we can try to solve that wallet problem. That's what I'm going to get into now. And you're going to be the first ones outside of the Hopper team who are actually testing that. So please forgive me if something fucks up. This is a product that's live since 2 days, which is running on top of infrastructure that is live since 7 days. So somebody is laughing. Yeah, please laugh when it fails. So yeah, what is RPCH? RPCH is, as we call it, a private RPC provider. Now, since we've been diving a little bit deeper into the whole thing, like, this is actually not true, but it's catchy and people understand what I'm talking about when I say it. So for this audience, RPCH is privacy middleware that sits between your wallet and the RPC provider and connects, or actually disconnects these two by the Hopper mixnet. So RPCH stands for RPC over Hopper. So we change the underlying transport infrastructure. When you edit a network to a MetaMask, you have this drop down. Again, it takes 1.5 seconds, obviously. You have this drop down here. These entries, let me actually unlock it and we can look at the entries. They all begin with HTTPS, right? So HTTP is using existing internet infrastructure, which is not privacy respecting. So add network. So all these networks basically begin in the RPC URL, begin with HTTPS, which is secure, right? It's end-to-end encrypted, but it's not private, in the sense that third parties can see exactly who you're pinging there. So that's what we want to fix. And therefore, we cannot use just another entry because all the entries on this list use HTTPS, which is not metadata private. So we need to do something else. So that's a bit tricky, right? Because Hopper is, as I said, live since in that version since 7 days. For some unfortunate reason, Brave has not integrated Hopper yet in these 7 days. Chances are that's not going to happen tomorrow, so we need to find a solution. And what we actually do, what I'm going to demo and we can do together here, is that we add a executable that's running on your computer in what I'm going to demo here is based on Docker. So the ones here who have Docker running, yeah, that's a Docker container that we'll install that is running a local instance to which you can connect your wallet, which is then taking these requests that reveal so much about you, breaks it up into indistinguishable looking packets that we've seen in a beautiful animation before, sends it through this Hopper network, and then sends it to an RPC provider. Remember when I said I was cheating a little bit when I said that Hopper is the private RPC provider? Well, you can send it to any of the centralized providers that we have today. But they will not see your IP address and they will not see that it came from you, right? They just see the exit node from which it was coming. And that looks kind of indistinguishable. It's used by a bunch of people, and therefore you have stronger privacy assumptions than even a VPN. So let's look into how that actually works. So I would like you to go, by the way, is there questions this far? Yes?
Will it also help with the time correlation that could be made? Because even if they don't know who you are or where it came from, if they see 2 requests that come in the same millisecond for 2 different addresses, they can see
There's not much you can do. Exactly. And also, if you have additional information such as header information, you're screwed. Basically, if the application is screwing you, there's nothing we can do. We can help you to get better than that if the application tries to, do a reasonable job. In a previous version, MetaMask had actually these batch requests, which in a single request was sending out all the addresses. So that's even more trivial. We got one step better now, half a year later. I think, if we're all bitching a bit more, maybe they just do individual requests and separating that. But you're absolutely right. If there's application layer, data or metadata that is being leaked, you can't fix that on the transport side. Other questions?
Why did you choose to mix and add latency to requests? rather than just obfuscate with a bunch of crap.
Yeah, so why did we choose to like fix latency instead of adding a bunch of crap? That's actually a good question, and in fact, we are doing both. So this adding a bunch of crap is translated in kind of academic terms. We call that cover traffic, right? So cover traffic is background noise. And if, you can imagine that if you're standing in a football stadium and you're shouting, I know it's you. If there's 50,000 other people who are shouting around you, I can't hear it you. So that is what's going on. We do that general purpose, again, on the transport layer, not with the RPC data. But in theory, what you could do is you could run some, something locally, a service that is, dispersing a bunch of random RPC requests from like vitalik.eth and whatnot, right? Yeah, you can totally do that. Good. Okay, so let's jump into RPC. So I would like to ask you to enter rpch.net, again, which stands for RPC over Hopper. And RPC over Hopper is, again, this additional layer, and we want to use it now. So in order to get access, it's a free alpha. Again, you're the first ones who actually use this thing. I would like you to hit the access button at the top right. Fonts are looking almost right. And you hit the dgen package. Is a dgen package because the only way to access that is unfortunately Docker. I know normal people are not going to use Docker. I hope some of you are. So in order to get started, because it's for you, we do not ask you to log in with Google. We ask you to log in with Ethereum. So I'm going to connect it to my MetaMask. MetaMask is going to ask me to sign some stuff. Whenever you sign something, please do check what you sign. When somebody asks you to sign random looking hex strings, please don't do it. Like there's standards that look better than this, which is this one here. So you say, sign in with Ethereum to RPCH dgen, the URL, chain ID, and so on. Looking good. Okay, please do not sign random hex strings. Lots of accidents happen there. Cool, I'm logged in. And that is basically to just enforce that, there's not people who just completely hammer us and overrun the network with a ton of requests, and we could just say, okay, for that client secret, we will just on the entry node side reject these requests. So this demo expects that you have Docker installed. If you do not have Docker installed, we have docs here which show you how to do that. I will not go through the Docker installation because, especially if you're on Windows, it's like a bit painful. If you're on Linux, congratulations. If you're on Mac, it's so-so. So you can basically just copy paste that one into your command line interface, into my terminal. I'm just gonna copy that one in. And what this does is let's take a very quick look at what this does here. It starts a Docker container, which is a translator between your wallet that you locally run and the Hopper network. Now, this thing is in its first version also not very smart. It doesn't really know the Hopper network. It needs to get introduced. So there's a central point of trust and failure, which is called a discovery platform. The discovery platform is basically your matchmaker. In this decentralized network, you're invited to the party, but you need to get to know other people. That's your matchmaker. If you don't like that, well, you got to run a Hopper node. Again, as a first version, I think it's still much more private than any VPN that you might have. So I think it's fair enough right now, but I want you to be aware of what is the trust assumptions of this network. So yeah, it pulls this thing and it exposes a locally running RPC server on port 45750. It's a little puzzle to figure out what the number stands for. I will not reveal it here. And that's what we will add to our MetaMask or whatever other wallet you have running locally. So I'm gonna run that. I have already pulled the image. So the first time you run it, it takes a bit longer because it's pulling the image. I already have that. And once your RPCH server, that's how we call it, this Docker container started, you see basically this message here. So some status time, RPC server started on. And yeah, there's some additional flags that I'll talk about later. Cool. So now this thing is running here. And I'll keep this running in the background. And there's a button down here, add Gnosis chain over RPCH.
Cool. Next.
Okay, sorry. For accessing for the first time, I didn't mention that. You need a code to actually pass this thing. Thank you. It's called free privacy in capital letters. Free privacy is the access code. Thank you, Felix, for that. I forgot to mention that because I was already logged in. So to get there, you log in with Ethereum. And in order to log in, you need the code free privacy. Very important. Please let me know if there's any issues. We had already a service crashing or whatnot. No? System's still alive. Cool. Yeah. If anybody managed to get that Docker container up and running, please feel free to show your hand up. Anybody get that far? Still loading. I'll give it a minute for you to load the images. So again, this is locally running. It's going to do this translation from taking the RPC requests, sending it through this mixnet. On the other side, when the response comes back, doing the same thing, taking requests, gluing them back together again. And therefore, for your wallet, this is transparent, right? So your wallet does not need to understand Hopper. The wallet does not need to understand mixnet. Now, how we cheat it here, basically, is you have to have this locally running container, this local container running. That's basically how we cheat it, right? Of course, the mid to long-term roadmap for us is we want to get that one integrated into wallets. So if you're working on a wallet, please come to us. We'd love to talk to you. If you're running on a, like if you're working on a web app that has like an integrated wallet or something, would be super happy to make it work like in like dApps directly as well. It's possible. We have an SDK. Basically, this Docker container is just running this SDK, instantiating it, and running it in a standalone fashion. But you can totally kind of, as a drop-in replacement for Web3.js or Ethers.js, for example, add to a wallet like that. So that's our goal, to make it much easier for normal world users and still offer them privacy that they deserve in the digital world. Yeah, okay. Anybody running the Docker container by now? Loading?
Slow Wi-Fi.
Slow Wi-Fi. Okay, cool. Good. I'm going to show you how it works on my side then.
I've got an error connecting to the custom network.
We'll get there. That means your Docker container is already up and running? If so, the last line that you should see when it's up and running is this RPC server verbis RPC server started on. So this line means it started. If you do not see that, it means it's still like loading and doing a bunch of things. So if you connect this network, it won't work, right? Because the thing is not up and running. So we try to make that easy for you. So we have this this button here for Gnosis chain over RPCH. I'm gonna hit that button. Damn it. Sorry, I had a cached version, so I need to sign in again. So the ones who need this passcode is free privacy, all capital letters, FREE, and you know how to write privacy, I hope. I'm going to add that to my MetaMask. So you just hit the button. If that doesn't work, if you're running a different wallet, you can find all the information in the docs. So you find this information in the docs. And now if we look again, who do we add here? So it's not some centralized server, it's localhost on port 45750. And the interesting thing here is we're passing it this provider flag. So it's a URL parameter. And that's how you can use derp, that's how you can use RPCH with any EVM chain. So if you want to run this thing on like whatever dgen L2 you want to, you can do that. As long as it's EVM compatible with the RPC standard, you can use it with any L1, L2, L3, whatever that you might like. You just need to adjust the URL parameter and pass it the RPC provider that actually serves this request coming from the exit node. So worst case assumption here, just briefly thinking about it, what does it mean? This exit node provider, the last one who translates this hopper into RPC call and responds back, they will see all your requests, but they do not see where it came from, right? So we have a separation of data, which is unfortunately not private. Many smart people working on that, I hope they succeed, from the metadata, like your IP address and your identity. So we separate these two, right? So it's important to realize that. Cool, so I'm going to add that, and the rest is just like the normal Gnosis chain. Approve. Good, so I approved the network. I'm going to switch the network. And similar things, just not as prettily rendered as before, pops up here. So you see requests that are being routed through my locally running translator service from RPC request to Hopper. So you see that this one was, let's see what was going on here, an ETH balance request, right? So my MetaMask is obviously doing this exact same thing as before. It routes requests and gets responses on the way back. And just to demo it, I'm going to go again on sushi.com, and I'm going to swap the same thing that I did before. I'm going to swap it back. So where is, it's already connected. Cool, so I'm going to swap it back, and we keep looking at the requests that pop up here. I purchased some GNO. Now I'm going to swap these GNO back. Proof GNO, we see a bunch of things are going on. Again, same thing that you saw before in kind of pretty rendering on the Derp website is now going through here, but now it's being made private. So I'm going to approve it. You see this big request here, which was probably an ETH estimate gas, right? This huge ass thing here. Wow. Okay, no idea what that was. Looks like a huge request. Okay, approve. Nice. Transaction failed. Unable to process. Internal JSON RPC. So probably I was waiting for too long. Let's try again. So I'm going to approve it again. Approve. Transaction failed. Okay, so I'm going to hit some error here. No idea what's going on. But in essence, we see these requests being routed in the exact same fashion as before, kind of through this mixnet from your wallet to this exit node and a response on the way back. And that's what you see kind of being locked down here and coming in and out. So here, what do you receive here? ETH gas price. So that is RPCH, which uses the underlying Hopper mixnet. And again, if you're working on a wallet, working on anything that is using RPC calls, happy to talk to you and think about how to integrate that, how to make use of that, how to make the Web3 more private than it is today. If there's any questions, happy to answer that later. Otherwise, thank you so much for joining me here today.
In terms of the mixnet and communicating between peers, when you bootstrap, what networking topology or networking protocol do you use underlying, say like UDP, libp2p, these kind of things?
So Hopper is based on libp2p, so it can use any sort of underlying transport that libp2p supports. And so it's quite flexible. So currently we recently shifted to Rust libp2p, so it's we had a JS libp2p, which was a bit painful, and now, that was quite a good transition.
And how wide is the k anonymity set at the moment?
Very small, because currently the entry and exit node is operated by us. That's what I mentioned before, so it's very small. We have currently in the network approximately 300 nodes running. What matters though is we have this payment channel topology. So in order, I didn't really get into Hopper here because I wanted to keep the discussion at the level of this RPC provider. So your node has a customizable strategy by which it opens payment channels. You can open payment channels to everyone here, or you can say, hey, I optimized for ROI, right? I open channels to a few select candidates and optimize my return of investment.
Cool, and sorry for the Hopper specific questions.
No, go ahead.
For each subsequent RPC request, does it essentially become non-replayable? So the next message that is sent along the Hopper network, is it able to be identified as relating to a preceding message?
It is for the exit node, yes. the exit node needs to know that they belong together. So basically, the current version of Hopper is a bit like UDP, in that you send individual packages. And that's why it's a bit painful to build applications on top of it. So we basically need to build TCP-like features on top of this UDP-like protocol, which, yeah, we know there's some work left for us. So, and that's why the exit node knows they belong together. So, yeah, we have a crypto paper description in the docs where you can find the details to it.
Sure, because it would be quite nice if the, say, like ETH estimate gas was completely disconnected from, say, the ETH send raw transaction.
That is the case. So that is actually the case because every packet goes a different route, but the exit provider needs to be able to glue them back together, right? So per request you hit the same one, but then in between, like, they all go different routes.
Cool, thank you.
Thank you.
Thanks for the talk. Do you have a plan for mobile, like running a Docker container there and like consuming so much data is a problem for a lot of users? Do you have an idea how to solve that?
Yeah, so in fact, that's one of the main reasons why we are migrating to Rust is, not just performance and stability, but also to much more easily support mobile ecosystems, which so far was hard. But yes, that's absolutely the plan. In terms of bandwidth, as a user, as long as you're not actually running a Hopper node, the bandwidth utilization is not going to be crazy. It's going to be higher than before because we pad the packets all to be to the same size and so on, and obviously have header overhead. But otherwise, it's not going to be too crazy. Like in the next version, you would run kind of like a small Hopper node on your device, and then the bandwidth overhead that you have is, well, it's really up to you. So there's this annoying trilemma. It's called the anonymity trilemma, which is a trade-off between low latency, low bandwidth overhead, and strong anonymity. And like in there you can choose, and for example, if you want like pretty decent privacy and pretty low latency, you need quite some data bandwidth. But basically our objective of Hopper is to give you a choice. You as an application developer or user should be in a position where you can make trade-offs in this triangle, because it's not going to be the same for all of us.
Yeah, I'm not that concerned about the data usage while running it. I'm more concerned now with the whole setup of Docker. Because like alone there, you transfer like 500 megabytes of all.
Exactly, yeah. So the current version, we are not complete with our Rust migration, so it's still running in a node engine, and then unfortunately it's big. Yeah. So the memory footprint we already managed to like significantly reduce. So I think currently it's like around 60 megabytes. And like if you run it in an optimized setting, but yeah, it's going to get there. It's going to be manageable.
Thank you so much.
If there's no more questions, I'm also around. You find us in the yellow t-shirts. Happy to answer any questions later on. Thank you so much. Stay private.